Hello Internet, my name is Quinn and this is Blondihacks. I'm back on my big steam engine project this week and I'm going to make the crosshead. This is a cool design on this because the crosshead bore is round, so we're going to have some really cool fixturing and operations to do on this one. So let's go. Here's the casting for the crosshead. It's cast iron and currently sprued to the eccentric strap, so I'll need to separate those. Before I do though, I want to take a look at the drawing and just kind of make a plan. In particular, I always want to know how much material do I have in each of the major dimensions. And right away we've got a curiosity with the length here. The casting is actually already shorter than the drawing says the final part is supposed to be, so that's a little disappointing. We'll just have to work around that, I guess. The next thing I'm looking at is the tolerances on the critical dimensions. Engines are really more about tolerances than dimensions. What's important is that the relationships between all the parts is correct. Especially as hobbyists, we're only making one of everything. It's not so important that everything be the exact right size as much as the relationships between them are maintained. So for example, on the crosshead there, the spot-faced area where it meets the clevis here, I want to check what the low end of one tolerance is compared to the high end of the other tolerance. In other words, what's the minimum acceptable gap? And that's what I'm going to aim for. So the dimensions on this part can be adjusted a little bit to aim for that minimum clearance with the mating part, depending on where I landed on the dimension with the mating part. So I'm focused on those tolerances more than the actual dimensions that are in the drawings. Then of course I'm going to fet all the casting, clean up all of the flashing. On the surfaces that will be machined, I'm getting rid of it in order to make it easier to set up and measure things before I start. And on areas that won't be machined, the cleanup is aesthetic, of course. I need a reference surface to get going here, so I think the top surface of the crosshead makes the most sense to use for that. I'm going to set it up here in the mill with some emery to grip the casting sides there, and I'm going to do my best to get it square. I mean, we have no valid references really yet. Everything's all casting surfaces, but you just sort of do your best to get it straight in every dimension here, and once we have a reference surface, then everything else will be done relative to that, of course. And then I just machine this down. Now this is the dimension that, remember, was already too short on the casting, so I'm just trying to remove as little material as I can here and hopefully not end up with a crosshead that's too disastrously short. As you can see, I've got a little bit of a low spot still in this back corner here, but I don't want to try and go any deeper there because that area is not critical, and again, just trying to remove as little material as possible. Now with that one reference surface, I can do a little bit of layout. I don't need to do much on this casting layout-wise, but I do want to establish a center line down the middle of it here. I'm definitely going to need it for the center hole, and it might be useful in other aspects of the setup here, so it seemed like a good idea. I'm clamping it to my angle plate there using the reference surface that we just created, and then I'm going to square up the sides here. Now again, those are rough cast sides, so they may be unpredictable, but it's all we've got here to start with. The next step is really just trial and error. I eyeball what seems like a good center line on the casting there with the height gauge, and I make a little mark. Then I bring in the dividers and I check the spacing between that mark and a useful cast detail on either side. Again, the goal here is to end up with the machined surfaces being nicely aligned with the unmachined ones. So since the rails there, the inside rails, will remain unmachined, I'm measuring my center line to those. And that was a little bit low, so I tried another mark a little bit higher up, and that one looked much better. It seems to be nicely centered there, so I went ahead and scribed that line all the way down. Now in principle, I should then be able to just rotate the part around, scribe the same line on the other side without changing anything, and it should be a valid center line. However, when I double check on the other side, it's actually not very well centered there. So I went ahead and made a separate center line on that side. Probably what that means is that these side rails that I tried to square up are not very square. There might be draft angle there, or there might be a little twist in the casting, something like that. So I've got independently determined center lines on both sides of the part, which I then connected around the back there. And this is really the one that I care about, the center line on the back there, because that's where the center hole is going to go, which is going to be the reference for a lot of other features on this part. And that looks pretty good there, so I think we've got a good center line. For the cross mark now, I'm using a technique that works well for me when there's room to do it. That's to take an odd leg divider set to the nominal half dimension of that surface there and just make a small arc from many different positions around the surface there. And that little mess of marks there that doesn't show up well on camera actually forms a decent center there. Now I'm going to set it up in the mill, and I need to get it level again with that reference surface. So I've got the tenths indicator out here because this is a very short surface, so I don't have a lot of room for error here. So I'm just going to tap this in until it's nice and level. This is going to set the squareness of the hole that I'm about to drill, so this is fairly important. And after a few rounds of tapping, I got it to within a couple of tenths of perfectly flat here, so I'm happy with that. Now to find my center line there, I've got my center drill out there and some magnification and good light, and I'm just lining up the tip of the center drill on where all of those little arcs that I created cross. A little spin by hand will create a round mark there, and that looks good. Then I can double check it by putting the pointy end of the odd leg calipers in the center mark there and just running it around the edges. You can feel it lightly dragging on the casting all the way around if you've got it right. Now I can center drill and drill. Now in hindsight, taking this out of the vise and then putting that center line on it and then putting it back in the vise and finding center and drilling it may have been a waste of time. I kind of thought that center line would be useful, so that's why I did it, but it didn't really turn out to be. As always on this channel, I'm not trying to show you the best way to do things. I'm just showing you how I did do it at the time based on what I knew and what I thought it would work, and there's always a better way. This starts by going very deep with a very small drill. You'll see why in a moment. There's actually quite a lot going on inside this crosshead. There's an entire tiny little lubrication system in there, which you'll see evolve here. So next I go in with the pilot drill size for the thread, and this only goes down part way, not nearly as far down as the little hole went. Then I tap some threads in there, but not even as far down as the tapping drill went. Once again, you'll see why. This is all actually very clever. I like this area of the design quite a bit. I'll shine some light down there so you can see what's going on. There's a tiny little oiling hole at the bottom which feeds the wrist pin. Then there's a wider hole above that which is actually a little oil reservoir. And then the threads for the piston rod are above that. So there's a little tiny oil reservoir hiding inside the crosshead. Very cool. We'll come back to this later. There's more to that little oiling system. But for now I'm going to set up some steel in the lathe here, and I'm going to face off the end as is tradition. I'm going to make a mandrel to turn the all-important outer diameter of this crosshead. Now I'm going to turn this down quite a ways. I'm going to make a mandrel that will hold the crosshead using the threaded bore that we just created. But there's a little twist here. There's going to be a reference boss on the end of this mandrel because I don't want to reference the turning we're about to do from the thread, because threads are not reliable positioning tools, if you like. There's a lot of clearance in threads, often as much as 10 thou with home gamer taps and dies. However, remember that little oil reservoir that's at the bottom of the thread. That is what's going to be my reference for turning this crosshead. I'm using the indicator on my carriage here to calculate a precise length for this little registration boss at the end. It needs to be just the right length to pick up that oil reservoir, but not bottom out in there and prevent the crosshead from seating down all the way. That slightly larger diameter has been turned for the thread, of course. Because that boss is sized to go through the thread, in principle, the die should actually go right over it without touching it, but it doesn't, which is kind of interesting. It does cut a little bit of a thread in that boss, which means that the tolerance on this die is a little different than the tolerance on the tap that I used, but that's okay. That's not going to cause us any trouble here. I verified that that boss is the exact size as a gauge pin that slides through past the major diameter of the threads in the hole and registers on the little oil reservoir. So just a funny little difference between different tap and die sets that you might encounter there. You can see that it's made a little bit of a threading impression on that boss there. I did deburr that and then verify the diameter of it because the threading die might have pushed up some material there, and indeed it did. So I had to come back and just skim the surface of that back down to where it's supposed to be for my little registration pin there. And now we are right on, so that should be a good slip fit in the little oil reservoir at the bottom. Next I'm going to undercut the base of the thread here because I need to make sure that the crosshead is going to seat down against the shoulder of the mandrel there. That's important for a good grip. And let's test fit this on here and see if it's going to work. So it threads on there, and then that boss is going to register down in the little oil reservoir, and then it seats all the way up against the shoulder there. So that's looking good. So there's a fair amount of little subtleties to this mandrel to make sure that I get a good repeatable reference and that it's going to be a good secure grip, and that looks really good. Now I'm going to put a little thread locker on there for insurance, but in principle this isn't necessary. The reason that you can use a thread as a cutting mandrel like this is because when the lathe is running in the normal forward direction, the cutting forces are upwards on the part, which acts to tighten the thread, so the part only gets tighter as you machine. All right, away we go. Let's make some chips. I'm using high-speed steel here because this is the very definition of an interrupted cut. And while carbide nowadays is certainly better at interrupted cuts than it used to be, still, this part is going to hammer the insert quite a bit, and I don't want to start setting $5 bills on fire. I start with a very light cut just by hand because with a casting you never know. There can be surprises. There might be draft angle here, there might be some flashing that you missed, there might be a hard spot, you never know. So a little light cut by hand just to see if there's anything crazy, and then I let the lathe start feeding on its own and we start making some real chips. With a cut like this, I also lock the cross slide on every pass because that part is like a little impact wrench on the tool, and it can cause the cross slide to shift out of position during the cut in a way that normal turning doesn't. Almost at a full cut now, still some low spots. Once I've got a full cut, then I'll start taking measurements. With a full cut now, I can start measuring my progress, and they give you lots and lots of material on this dimension, which is nice. It's always better to get more material than less because it gives you more margin for error and more options in how you set up the part. Much nicer than the negative extra material they gave me in the other dimension. This should be my final pass here, so I'll take some final measurements now. I'm checking for taper as well, so I'm checking in a few places all the way down the length. I ended up 2 thou over nominal at the top of the tolerance on the crosshead bore because of the lapping that I did, so I'm aiming for 1 thou and a hair over on this part, and that is looking really, really good. I'm very pleased with that dimension. This is a perfect example of what I was saying earlier about comparing tolerances more than dimensions. Comparing the high end of the crosshead tolerance to the low end of the bore tolerance tells me that the minimum ideal gap here is 1/1000th. So I'm aiming for just a hair less than 1 thou clearance in case I miss it, hence my target of 1/501 and a few tenths here. If possible, I like to do a test fit before I take the part down off the setup, just in case. If I need to make an adjustment, now is the time. Now that doesn't quite go in there, and this is the model engineer's dilemma. If the test fit fails, do you trust your feelings with the test fit, or do you trust the dimensions that you've been measuring? That's always a tricky thing. There's a little bit of a judgment call there. Now on video you can see why it isn't fitting. It's because I'm not holding the frame straight there. It's a very awkward heavy casting, and it's difficult to tell when you're holding it straight. So I decided to trust my dimensions here because I measured and remeasured the bore and the crosshead multiple times, and the math was very clear that this thing should fit, so I did not dare take another cut off of it. Instead, I just put in the chamfer tool and I'm going to break those edges there, those rough cast edges. Sometimes there's a burr that's keeping a test fit from succeeding as well, and I want to have those just slightly chamfered anyway to help that move in the bore. And now I'm going to go ahead and take this part off the lathe. Once again, I'm trusting my instruments and the math more than my fifis on this one. And that was very tight indeed on there, partly from the turning and from the Loctite, I'm sure. The Loctite was almost certainly overkill, but you can see that it certainly did its job there. Okay, moment of truth. I'll get a little bit of oil in there, and let's see if I made a mistake by taking that part off of the setup. It's a close fit, so it has to be very, very straight for it to go in. And that seems to slide in there. And, yes, that is a beautiful sliding fit. Oh, that is just deadly. Wow. So good thing I trusted the instruments and the math, and not my fifis. Oh, hey, look, it's our friend, the connecting rod. You may recall that I made this thing 34 thou too short. Well, I'm just verifying that error here, and now I'm going to mock it up in the engine because this is my first chance to compensate for that error. So just kind of mocking up where the pivot on the crosshead is going to land at the bottom of the bore once it's mating with the connecting rod. Kind of some eyeballing here. It's a little bit difficult to tell because I can't fit the parts together yet until I finish machining the crosshead. But what I'm checking for is how much extra travel there is at the bottom of the bore. Because if I do nothing, the crosshead will slide down an extra 34 thou at the bottom of the bore because the connecting rod is too short. And what I found was that actually the travel of the crosshead is very, very close to the bottom of the bore. It actually sticks down below the bottom a little bit, probably to help keep the bore clean. If there's any trash in there, it'll get pushed out the bottom. So I definitely don't want the crosshead running any lower than it already is, though. So that makes the decision for me here. Stay tuned on that. I'm going to use V-blocks to set this up in the mill. They're going to hold those curved surfaces nicely there. And once again, I'm referencing everything from that little oil reservoir in the center there. I don't necessarily trust the V-blocks because they might be touching those cast edges a little bit. So that's why I'm centering up using a gauge pin here. But in principle, you could center up using the edges of the V-blocks as well. And I also need to pick up that top surface of the cross slide there. From that top surface, I translate down the distance specified in the drawing for the pivot plus the 34 thou that I'm going to add for my connecting rod error. What this does is effectively shifts the pivot point of the crosshead down, which compensates for the connecting rod error without changing the range of travel of the crosshead. I wasn't sure if I was going to have enough material to do that change here, but I do. The other option would have been the piston rod if there had been extra travel in the bore for the crosshead. Interestingly, the casting has a dimple cast into it, which I guess is supposed to be a helping starter for this hole, but honestly, it's just going to cause the drill to deflect in weird ways, and it's just going to be in the way. So I'm going to mill that out of there first before I try to drill my hole. I've got a 2-flute center cutting end mill here, so I'm just milling down until I've got a nice flat spot there, and that weird cast pocket there is all gone. Then I can center drill in the center of my pocket and drill through with confidence that the hole is going to go only where I want it to and not where some part of the casting feels like it should be. I went up in 2 drill sizes, finishing with the pilot drill for the reamer, and then I reamed the hole to final dimension there. The next little feature is kind of a tricky one. The drawing calls for a 7/8 spot face on both sides of this bore for the clevis to run in, and I don't have any easy way to create a feature like that. I thought I would start by trying the boring head. In principle, the tool grind on a boring head allows it to be used as a mill of variable diameter, so I thought I'd give this a shot. I put a little bit of diameter on it, and I did a light test cut here across the top of the casting, and that seemed to go well. So the next step would be to establish the diameter of the boring head, which is kind of a trial and error process. So I set up a scrap of aluminum here outboard of my setup so I didn't have to disturb it. And I made a series of test cuts, enlarging the boring head a bit at a time as I went to get to the final dimension of 7/8 before I went in on the cast iron. However, what I found with this test cut is that once the diameter got larger, this started chattering like crazy, even in very light cuts on aluminum, which is a much easier material. So this was absolutely not going to work. Boring bar is really not intended to be used for side milling like that. I was just hoping I could get away with it. But I can't, so plan B is I've got the largest end mill that I have, which is 3/4, and I'm going to use this for the spot face and just create kind of a squared off face instead of a nice round 7/8 circle like the drawing specifies. To start with though, I'm just milling down till I'm about flush with those side ribs, and then I'm going to flip the part over and do the same thing on the other side. I'm using a gauge pin here through that bore to get the part horizontal once again so that this face will be parallel to the opposite one, and I mill down to roughly the same depth. The depth that I'm starting with here is one that will clean up most of the area and I know is smaller than the final spot face needs to be, so it's just sort of a starting point. Now I can take some measurements. The trick here is that I want the spot face to be centered on the casting using the crosshead bore surfaces as the reference. So that's the trick. To do that, I'm setting it up on the surface plate with the V-blocks once again and using a gauge pin to get it vertical there, just kind of using the end of the gauge pin on the surface plate there to square it up. Then I find a series of gauge blocks that is a perfect fit underneath that surface. I make a note of that. I flip the part over and I do the same thing again. Then at the end of this process, now I have a map of how much material I need to remove and how much from which sides in order to balance the cuts and end up with two surfaces that are equidistant from the center line of where the crosshead is going to run in the bore and also the correct thickness. Now I can mill that top surface down to the final dimension that I determined with the gauge blocks there. Then I move it over as close as I dare get to the V-block there to get the width that I need. I don't quite have enough clearance here to get the full 7/8 of width, but I can get pretty close. I think hopefully close enough. Then I do the same thing on the other side. Then I flip the part over and I do all of that again, and I end up with my two spot-faced surfaces there. So, moment of truth, let's see if the clevis fits in there. If I did my job right, it should be a nice close sliding fit over the clevis, and there should be clearance around it for the full range of travel there. And that looks really good, so it looks like the full 7/8 spot face in the drawing is not actually necessary, which is good news. Next little part I need is the wrist pin. The kit supplies this hexagonal steel bar stock for the purpose, and they're pretty stingy with it. You gotta really be careful or you won't have enough of this stuff to get both parts out of it. I'm going to start with the bolt. It's a long shouldered bolt, which seems like a straightforward part, but there's some very critical dimensions on this, so you really got to take your time. I'm using emery paper here to get a really good finish on this and make sure it's right on dimension with no taper in it, because this is going to be the pivot pin for the crosshead. It's a very important part. The shoulder also has to be just the right width, so I'm setting the tool there with a gauge block stack. You want this shoulder to be about 1/1000th wider than the clevis is, so that the nut clamps down on the shoulder of the bolt and not on the clevis. So after doing that cut, I verify again with the gauge block stack that I have a little bit of end float there, so that the nut will not clamp down on the clevis. And then a quick test fit there, and you can see I've got just a little bit of a shoulder there that I can feel outboard of the clevis. So that's what I want. Now I can go ahead and put that thread on there. Then I also undercut that thread because I want to make sure that the clamping nut seats down tightly on that shoulder. And Yahtzee. The remaining stub of material there is then drilled and tapped and chamfered and parted to create a matching nut. Alright, we've got enough parts to test fit here, so I'll put the crosshead and the clevis together there, and then that little shouldered bolt should go through the center there. Again, this is much more than just a bolt. It really is a precision part. If it isn't made just right, then there's going to be sloppiness in this connection here, which is no good at all. That looks really good. I'm really happy with that. And well, I mean, we got to put it in the frame now, right? Because we got to see how it runs. So I'll slide the crosshead in there and then slide it down into the clevis and get that pin in there. It's a good sign that it's actually quite difficult to get the wrist pin in there, because that means that the two bores and the pin itself are all very close in dimension, which is what I want. Once again, that pin is oiled from the little reservoir that's inside the crosshead, which is very clever. And that runs beautifully. Very, very pleased with that. Now, speaking of that oil reservoir, I actually almost forgot to do this, but there's a couple more details here that we need to do on this. There's a little angled filler hole for that reservoir, so it's at a 60-degree angle on the final part, so I'm setting this part to 30 degrees since it's lying sideways. I mill a flat spot and then center drill and drill a very tiny little hole, and this angled hole, if done correctly, comes out inside that little reservoir below the threads for the piston rod there. I'll stick a little drill in there so you can kind of see what that looks like. So that's the little oil filler neck, if you will, for the crosshead. There's another interesting oiling feature here though. There's a cross hole all the way through this thing. Now I'm setting it up sideways here with packing blocks on those spot faces, and I've got tall parallels inboard here so that the curvature is sitting on the parallels and not the cast edges, which are unreliable. And then it's a simple matter of center drilling and drilling a tiny hole all the way down through this thing, which was right at the limit of this drill. If I did that right, I should be able to create an old faithful of crud here. This geyser is less popular with the tourists. This horizontal hole goes right through the side of that reservoir. I'm not exactly sure what it's for. The bore has its own oiling system, so it might be just kind of an equalizer. It allows the crosshead and the bore to share oil back and forth as needed. Not really sure, but the wrist pin should be well lubricated anyway. Well, there's the final crosshead. I'm very pleased with that. This part was a lot of fun to make, a lot of interesting little setups, and I really did have to think through the order of operations there carefully. I hope you enjoyed watching me make it. Thank you very much for watching, and thanks so much to my patrons who make all of this possible. You all are the real heroes here, and I will see you next time.